Today, we're diving into something pretty amazing, your body's own power plant. We're going to uncover the incredible story of how every single breath you take gets turned into the energy that, well, fuels your entire life. It's a process we all kind of take for granted, but get this, it's happening in trillions of your cells this very second. You know that feeling, right? You've just finished a hard sprint. You cross that imaginary finish line, and you're just gasping for air. It feels like you can't get enough in. Well, that intense, desperate feeling, that's actually our perfect jumping off point today, because it's a clue that connects us directly to a super powerful process happening in like every corner of your body. Okay, so first things first, we need to figure out what respiration actually is. And trust me, it's about way more than just breathing in and out. By the end of this, you'll see it's a whole different ballgame. So, at its core, respiration is basically a chemical reaction. It's how your cells take the fuel from your food, we're talking about a sugar called glucose, and turn it into energy they can actually use. And without this, nothing. No movement, no growing, not even staying warm. It's that fundamental. And right here is where most people get it twisted. See, breathing, that's the physical part, moving air in and out of your lungs. But respiration, that's the chemical reaction that happens inside every single one of your cells to make energy. They definitely work together, but they are not the same thing at all. So where does all this magic happen? Well, it all goes down inside these tiny little structures called mitochondria. Seriously, just think of them as microscopic power plants. They're just humming away inside your cells 24/7, turning that food fuel into the energy that keeps you going. All right, let's talk about the body's go-to method. This is the main engine, Plan A. It's called aerobic respiration, and it's literally what's powering you right now, this very moment. It's the super efficient default mode. And the process is actually kind of like a simple recipe. Step 1, you start with some glucose from your food. Step 2, you add in the oxygen you're breathing. Step 3, the mitochondria mix them together. And the result? A huge amount of energy. It's a really clean and honestly an amazingly effective way to power your whole body. And if you want to see it written out, here it is. Glucose plus oxygen gives you carbon dioxide, water, and a whole lot of energy. The byproducts are totally simple, right? You just breathe out the CO2. It really is a perfect system. But what happens when you push that perfect system a little too hard? Okay, let's rewind. You're back in that sprint. You were going all out, so hard that your breathing just can't keep up. Your muscles are screaming for more oxygen than you can possibly give them. So what does your body do? Well, it flicks a switch. It turns on the emergency backup generator, and that's called anaerobic respiration. Now, just look at how different this reaction is. See what's missing? No oxygen. The body is just breaking down glucose all on its own. The problem? Well, for one, it makes way less energy. And two, it creates this nasty byproduct called lactic acid. And this is the thing you actually feel. That lactic acid, that's the burn. That's the muscle pain and the cramps you get when you're really pushing it. It's your body's emergency plan, for sure, but man, it comes at a cost. It's what makes you feel tired and eventually forces you to slow down. So the sprint is over. You've stopped running, but you're still panting, gasping for air. Why is that? Well, your body's got to clean up the mess that emergency generator left behind. It's time to pay back something called an oxygen debt. Yeah, all that heavy breathing you're doing after you stop, that's your body gulping down extra oxygen specifically to break down all that lactic acid and turn it into stuff that won't hurt you. You're literally repaying the oxygen your muscles were starved of during that intense sprint. Okay, so now we kind of get what's happening deep down at the cellular level. But how does that all-important oxygen even get there? Let's zoom out a bit and look at the amazing machinery that makes it all happen. Your respiratory system. Your lungs, they're basically the gateway, right? They're the connection point between the air out there and the trillions of cells inside you. Their whole job is just to bring in the good stuff, oxygen, and get rid of the bad stuff, carbon dioxide. But the real action, that happens on a much smaller scale. Deep inside your lungs, you've got millions of these tiny little air sacs. They're called alveoli. And this is ground zero. This is the exact spot where oxygen jumps from the air you just breathed into your blood and where the carbon dioxide waste jumps out. And get ready for this because the scale here is just mind-blowing. In your lungs, you have somewhere around 300 million of these little sacs. And if you could somehow take them all out and spread them flat, they'd cover about 70 square meters.
That is literally the size of a tennis court. A tennis court's worth of surface area packed inside your chest. How wild is that?
And they're just built for speed. I mean, you've got this huge surface area, walls that are only one single cell thick, and a ton of blood vessels right there. All of that means gases can zip between your lungs and your blood almost instantly. And you can see the results pretty clearly. The air you breathe in, it's loaded with oxygen. The air you breathe out, a lot of that oxygen is gone because your body just used it. And at the same time, the amount of that carbon dioxide waste product shoots way up. It's a perfect swap every single time. So the next time you find yourself catching your breath, maybe after a workout, pause and think about this. Are you just thinking about your lungs, or are you thinking about your mitochondria? Because you're not just filling up with air. You are delivering fuel to trillions of microscopic power plants, paying off an energy debt and resetting the very system that keeps you alive. It's not just breathing, it's respiration.